So moving on to example 2, we've got Richard Lloyd deposits $200 at the end of each quarter, so every 3 months, in an account that pays 7.5% compounded quarterly. We are looking at this guy and we are beginning to train our brains to think to ourselves, gee, are we dealing with an annuity here, or are we dealing with compound interest, or a mixture of both for this problem? So this guy is making regular payments, which means that it's an annuity, and it is drawing 7.5% compounded quarterly. How much will he have in the account in 10 years? So let's Sermton this thing up. And we are going to know that our formula is S equals this junk. One moment. Sorry, everyone, I had to look it up. So how much money will be in his account after 10 years? Let's fill in the blanks here. So we don't know the future value of the account. $200 is going in every month. The rate is 0.075. M is the number of compounding periods in a year. It's quarterly, so that's 4. T, we're starting off here with 10 years. The I is R over M, so 0.075 divided by 4. And N is MT, so 4 times 10, it's going to be 40. And so I'm going to go ahead, I don't know what that 0.075 divided by 4 is. Let's get a look here. So 0.075 divided by 4. That is going to be 0.01875. And so I could again put in the fraction or the decimal. Either one is going to be okay. And as I've said previously in one of my examples, please make sure that if you get a repeating decimal, that you either put in like 12 digits or you just go ahead and put the fraction in, because if you cut the decimal off too short, your answer is not going to come out accurate. And so let's go ahead and fill the information in here, everyone. We've got S equals 1 plus, what is I, 0.01875 to the power of 40 minus 1 over 0.01875. And so giving that to Wolfram, I can scroll back up here to get my future value of an annuity formula. It's also on slide 4, I believe, somewhere up there. And so there's our annuity formula. $200 goes in. The I is 0.01875. The N is 40. Again, the I is 0.01875. This dude is going to end up in 10 years with $11,758. $39. So let's go through these and think, everyone, how much did he invest? He invested $200 4 times a year for 10 years. So that's $800 a year times 8 years. So he invested $8,000. It grew to be $11,758.39 in 10 years. And so that's the sort of explanation for these that I'm looking for in the answers, everyone. We should be thinking through these pretty deeply, because they are actually very valuable problems. And so an answer like 11,758.39 means nothing. A statement like this is pretty powerful. So we can even add to this further to say he gained $3,758. It's a terrible looking writing. $3,758.39 for doing nothing in that 10 years. And so as we go through the rest of this problem, everyone, I've sort of set this problem up for us to just sort of see the effect that time has on something like this. And so the way that I'm going to do this is I'm going to make a table down here for us to line some numbers up. I'll make that table while I pause the video, and I will be right back. So I've set this table up, everyone, so that we can sort of see what's happening to this investment over time. And the only thing that we are going to be changing is the amount of time that this continues on. And so for 10 years, we can see that he invested 8,000 bucks. The total value at that time was 11,758.39, and that he gained $3,758.39. So we're going to play with this a little bit, and we are going to change the amount of time. And so that's going to only affect the n, because that's the only place time occurs in our formula. And so I just need to do a little bit of math in my head as we do this. And so instead of 40 in 20 years, it's going to be 80. Let's take a look at what happens to the value of this after 20 years. It jumps to 36,478. 64. And the amount gained is 20,000. Crazy. $478.64. So we can see, everyone, that the difference between here, he only gained 3,758 bucks, which is not very good. If you leave it in there for another 10 years and you keep doing the same thing, it jumps to a gain of $20,000, which is a lot, obviously. Let's go ahead and see what happens over the next 10-year period. So instead of 80, we are going to have 120 compounding periods. And remember, during this time, he is putting money in. It is still an annuity. So as we saw from my demonstration earlier, he's making a payment, it's growing, 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 he's making a payment, it's growing. And so it's behaving like that as we go along here. So let's look at what we end up with for 30 years. He ends up with 88,000. In 30 years, he's put in 24,000 bucks. Now he's got 88,449. 23. So the amount gained there is 64,449.23. And so in 30 years, he's gaining $64,000 for doing nothing except for shoving money into this account. Every 3 months, he's putting 200 bucks away. And our last one, everyone, over 40 years. So 40 times 4 is going to be 160 compounding periods. We end up with a total value of $197,709.58. And so the total amount gained there, everyone, is going to be $165,709.58. Again, made for doing nothing. And so there's a couple things we need to notice in this table that I've made here. Number one is that after 40 years, he only invested $32,000, and that went up in value about 5 times. And so he made $5 or so for every dollar that he invested. That's doing it for 40 years. If he only did it for 30 years, that would have gone up about 3 times. And so he would have made only $3 for every dollar invested. So you can see that that last 10 years has a gigantic, enormous impact. Let's just, for the sake of giggles, everyone, go ahead and add 100 years to this. And I know that this is not real. Nobody's going to do this. Well, it's possible. You could start an account and then pass the account to your child or something like that. If this was done for 100 years, $80,000 would be invested in the account. The number of compounding periods would be 400. And this account would grow to be 17 million $981,249 and 66 cents. And so you can see that the amount gained in that instance would be about $17,901,249.66. I'm running out of room on the page because the number is so big. So you can see, everyone, that if as the time of this increases, the gain that is happening grows to just ridiculous amounts, and the money just begins to grow incredibly fast. So again, time is fertilizer for money. If you're going to do some investing, it behooves you and it helps you to start doing that now. And again, this is something that you could start and leave for generations, continuing to grow this fund and build what we call generational wealth. That's going to be it for this example. I sort of like that one. That was pretty cool.